In this video, we'll be talking about how to integrate a combination of sine and cosine. The first thing that you would want to do would be to check your exponents. There are only two possibilities in here, whether both your exponents here are even. If not, then move on to the other condition. If there is either an odd or both odd number. In our case, we have 2 and 5 in here. 5 here is an odd number. Whenever we have an odd exponent within the combination of these two, just focus on the one with the odd exponent and just leave the one that has an even exponent first. So this would be the integral of sine squared of x. And for the one that has the odd exponent, you would want to just use the rules of integration regarding this one. Since what we have here is the integral of cosine that has an odd exponent, the first thing that we want to do would be to factor out one cosine of x in there. This would be cosine to the power 4 of x multiplied by the factored out cosine of x dx. And the next step would be to transform what's left into their trigonometric identity. Based on the Pythagorean identity for trigonometric, sine squared of x plus cosine squared of x is equal to 1. Since what we are focusing here would be cosine, put sine squared of x to the other side, which makes this cosine squared of x be equal to 1 minus sine squared of x. Since what we need here is cosine squared of x, we can rewrite this as cosine squared of x to the power of 2. This is the same as cosine to the power 4 of x. Now that we have that, transform this one. And copy the rest first. Now that we have that, we can first expand this expression. The formula for this would be a minus b squared would be equal to a squared minus twice multiplied by a and b plus b squared. So this would be a here is 1 and b here is sine squared of x. By the formula, this would be 1 squared, which is simply 1, minus twice multiplied by a, which is 1, and b, which is sine squared of x, plus b squared, which is sine squared of x raised to the power of 2, which is sine to the power 4 of x. And copy the rest first. Next step would be to distribute sine squared of x among the parentheses. So this would be the integral of sine squared of x minus 2 sine squared of x multiplied by sine squared of x would be sine to the power 4 of x plus sine to the power 4 multiplied by sine squared would be sine to the power of 6 of x. Copy the rest again. Now that we have reached this, we can see here that we have a lot of sine, and thus let u here be sine of x. Take the derivative next whenever you are doing a u substitution. The derivative of sine of x would be cosine of x dx. Put dx here since it is respect to x, and generally you would want to isolate dx here now. This would be dx equal to du over cosine of x. Now that we have our values here, let us substitute it into this integral of ours. It would be the integral of sine squared of x would be u squared minus 2u to the power of 4 plus u to the power of 6 multiplied by cosine of x. And dx right here would be equal to du over cosine of x. We can see here that cosine of x would cancel, leaving you with a du. And now we have this simple equation. We can integrate this one by one via power rule. First up, the integral of u squared would be u to the power of 3 over 3 minus 2 multiplied by the integral of u to the power of 4 would be u to the power of 5 over 5 plus the integral of this one would be u to the power of 7 over 7 plus c. And now your final answer would be reverting u back into sine of x, which would be equal to sine cube of x over 3 minus 2 sine cube of x. Sine to the power of 5 of x over 5 plus sine to the power of 7 of x over 7 plus c. Let us move on to our next example. You can see here that both exponents now are actually odd. So what we are going to do here would be to just use the same method as we did previous problem. But in our case, since both exponents here are odd, we can choose either sine of x or cosine of x. In here, let us choose sine of x and leave cosine of x now. For the rules of an odd exponent of sine, we must first factor out sine of x. So this would be the integral of sine squared of x multiplied by the factored out sine of x. And copy the rest first. And the next step would be to transform what's left into their trigonometric identity. Once again, for the Pythagorean identity, sine squared of x plus cosine squared of x be equal to 1. Putting cosine squared of x to the other side, you would have a value of sine squared of x equal to 1 minus cosine squared of x. Since what we already have here is sine squared of x, just directly transform that. And copy the rest. And now that we have this, actually for the factored out sine of x, it is now actually part of dx if we would want to look at it that way. So we can like move sine of x as part of dx. You would see why it is I said that it is part of dx later on when we would do u substitution. And now the next step would be to distribute cosine cube of x among the parentheses. And copy the rest. And now that you have reached this step, it would be wise to do u substitution once again. Let u here now be cosine of x. The derivative of cosine of x would be equal to negative sine of x dx. And now as you can see here, we have sine of x dx as du, and we have sine of x dx here. So that is why I told you earlier that it is part of dx now, the factored out sine of x. But for convenience sake, I will just like isolate dx here again. So this would be du over negative sine of x. So by that, this would be the integral of u to the power of 3 minus u to the power of 5 multiplied by sine of x multiplied by dx, which is equal to negative du over sine of x. And you can actually see here that sine of x would cancel, leaving you with a negative du. But we would not want that to happen, so we can put this negative sign outside the integral. So this would be negative integral of this one multiplied by du. If you also want, you can see here that we have negative sine of x dx and we have sine of x dx here. And it is also equal to du. So if you would want, just put this as du. But since this is negative, it would be negative du, which brings us to this one also. If you would put this as u now. And now the next step would be to integrate this via power rule again. But don't forget the negative sign. So this would be negative and put like a bracket, whichever you want, which represents the integral of this one. Integral of u cubed would be u to the power of 4 over 4 minus the integral of u to the power of 5, which is u to the power of 6 over 6 plus c. Distribute the negative sign. So this would be negative u to the power of 4 over 4 plus u to the power of 6 over 6 plus c. And now for your final answer for this integral would be equal to negative cosine to the power of 4 of x over 4 plus cosine to the power of 6 of x over 6 plus c. Just revert u back into cosine of x, and you would have your final answer. Let us try the second possibility, wherein if you choose the cosine cube of x, so this would be the integral of sine cube of x multiplied by the rule for this would be factoring out cosine x again. This would be cosine squared of x multiplied by the factor dot cosine of x dx. And the next step would be to transform this into its identity. I will just put it in order to avoid repetition. So since what we want here is cosine of x, transposing sine squared of x to the other side. So this would be 1 minus sine squared of x, and copy the rest. And the next step would be to distribute sine cube of x among the parentheses again. Once again, the factored out cosine of x would be part of dx, just like what we did earlier. Now, since what we have here is sine now, let u here be sine of x, and taking the derivative, it is equal to cosine of x dx. You can see here now that cosine of x dx corresponds to du. So we can simply substitute that, making this the integral of u to the power of 3 minus u to the power of 5 of du. If you would want, you can just isolate dx again, which would be equal to du over cosine of x. So if we would want to do that, copy cosine of x again, and the value of dx, which is du over cosine of x. You can see here that cosine of x would cancel each other out, which leaves you with a du. And now integrating this, you would have a value of u to the power of 4 over 4 minus u to the power of 6 over 6 plus c. And for your final answer would be putting u back into their original form, which is sine of x here now. This would be sine to the power 4 of x over 4 minus sine to the power 6 of x over 6 plus c. For this one, you can see here that we have a sine here as our final answer, but in our previous method, we have a cosine. I would want you to notice the opposition of the sign in those. For the cosine, we have a negative here and a positive. But in our case here, we have a positive and a negative sign. If you would want to input some values in there, it would be exactly the same. Because once again, basing on this, it would be the same. So don't be afraid whether you would want to choose this one or this one. You would arrive at the same answer, whether that is called a sine or a cosine.